Hey guys, very quickly about the parent function for the absolute value function. Right here you can see this is the parent function. It goes through the origin, and if I did zoom in on this, notice you have your pattern of 1, positive 1, negative 1, positive 1, because remember absolute value cannot have a negative number. The way that we would make this graph have a negative number is, of course, if we shifted it down. Notice that the graph has shifted down 4 units, of course, when I type in -4 on the outside. Notice if I type -4 on the inside, this graph went in the opposite direction. -4 went +4. Also remember that if you have a negative on the outside, it is going to flip that graph upside down. Let me move this up just a little bit. All right, so here we are. It is upside down because we have a negative on the outside. Also remember that you can certainly have a vertical stretch or a vertical shrink. If I make this a -2, notice that graph gets a little closer to the y-axis because it's getting compressed in. It's vertically stretching in. And of course, if I change this to a fraction, notice that the graph is getting wide. And of course, we're going to have those crazy b values on the inside. So of course, if I put a 4 on the inside, remember that is a vertical compression of 1/4. I'm sorry, that is a horizontal compression of 1/4. And remember, if we did make this a fraction, that is a horizontal stretch by a factor of 2, because of course that is a half and you would flip that upside down. So let's go ahead and take a look at some graphs and write some equations and draw some actual graphs. So this is in your packet. Go ahead and find this page, or if you are in class, I did do a couple of updates. KVA kiddos, look down here at problem number 5. I altered that especially for you. You are so lucky that I changed that for you, because after all, you're in pre-AP and you need a little challenge, right? So make sure you change that if you are following along in the packet. Face-to-face kiddos, you already have the update. So what we're going to do is we are just going to graph this based on the transformation. So let me grab a marker and we're going to get started. So again, we have f of and then parentheses x plus 2. So remember, we really want to identify the vertex. Everything starts with a vertex. So even though I don't have a vertex labeled here, I'm going to go ahead and make sure that I label all of those for my graphs. So the vertex here is going to be at -2, 0. And I know that's 0 because I don't have anything added or subtracted down here. So that's going to be the vertex. So I'm going to actually hop down on number 4 because number 4 actually has something added or subtracted. So if I was going to write the vertex for number 4, I'm just looking at HK, and that is going to be a +1, +2. Okay, so I'm getting ahead of myself. Let's go ahead and go back up to problem 1. So to find this value right here, we're going to start at -2, 0. And then from there, what I would do is do my sideways movement. So if I go one place, let me kind of make a chart here. And it's the a value times the sideways movement. And that's going to tell me if I go up or down. And we are always going to use this little chart. So remember, for a regular parent function, remember +1 for an x value gave us +1 for a y value. -1 for an x value gave us -1 for a y value. And what I'm talking about is this parent function right here. So let me go ahead and delete all of my edits here. Let me go and reverse that negative. And this is what I'm talking about. Notice the ordered pairs on here. And in fact, let me just bring up a table. Notice these are all -1, +1, 0, 0, 1, 1, 2, 2. And if I'd scroll up here, it would be -2, -3 to +3 and stuff like that. So let's use that based on our chart. I do not have any a value right here. So if I went over in the positive direction, +1, I would go up 1. If I go back to the vertex and go in a negative direction, It's still going to be a positive 1 output. So usually when you graph any function in here, we really require 5 points. We require your vertex and then 2 additional points on either side. So I've got 3 up to -2 is going to be a positive up to. So that is going to be a perfect graph with full credit. And remember, your domain is -infinity to positive infinity. And there is no vertical movement up or down the y-axis. So the range is still going to stay 0 to infinity. So for your intercepts, we have an intercept at HK, of course. That's your x-intercept. And then your y-intercept is going to be 0, 2. 0, 2. And then, of course, your transformation, that's just going to be 2 units to the left. So let's go ahead and talk about this one right here. Again, there's no a value. There's not going to be a stretch or a shrink, but this graph has been shifted down 2 units. So your absolute value graph for number 2 is going to look like this. And please remember, your domain is still -infinity to positive infinity, but since the graph got shifted down, it is going to be a -2 to positive infinity. And if you notice, you have your x-intercept at 2, 0, and your y-intercept is at -2, 0. Uh-oh, that's a 0, and let's make that a -2. So what are the transformations, y'all? It's just 2 units down. And then your vertex is at 0, 2. For this next one, you finally have a vertical compression, because it is a fraction, which means the graph is going to get pretty wide. So for your let's go ahead and start with your vertex. There's nothing in there in the absolute value bars. There's nothing being added or subtracted, so it is just 0, 0. So right here, that is going to be the beginning of our graph. And we know that that V shape is going to open up because we do have a number out there, but the number is positive. So here we go. So I'm going to go back to this guy. This is my sideways movement chart. And in fact, I'm going to write this on a separate sheet of paper because I really want you guys to grab this concept. All right, sideways. It is always the a value times whatever function we're in. We're in the absolute value function, so it's going to be a times the absolute value. And then that's going to tell us whether we go up or down. So right here, from the vertex, if I go one place from the vertex, it is going to be the a value times the absolute value of that one place. Of course, the absolute value is 1, so 1 times 1/4 is 1/4. And if you know anything about me when it comes to graphing, I hate graphing things that are not nice and clean and on those lines. So that would be the ordered pair, but I'm not graphing that because that's too hard for me. So instead of that, what I'm going to do is I'm going to figure out what could I divide by 4 where I get a nice, clean, easy whole number. And of course, the number 4 is going to be that for me. So I'm going to plug in a 4 right here. I'm going to take that 4 and multiply it by the absolute value of the a value. Absolute value is 4. 4 times the 4th is 1. I am definitely graphing that point. That's going to be easy for me to graph. And same for the other direction. So I can go in the -4 direction from the vertex. And it's going to be 1/4 times the absolute value of -4. And remember, that's still positive. So if I go in the negative direction, it's going to be up 1 for my vertical movement. So let's go back to my vertex. And let's just map these out. 4 to the right, 1 up. 4 to the left, 1 up. 1, 2, 3, 4. So there's a point. And of course, again, I do want 5 points typically, but 5 points are not going to fit on here. So 3 it is. And that is a pretty wide graph, which makes sense because we have a vertical compression. So your domain, negative to positive infinity. Your range is from 0 to infinity. And your x and y intercept are the same exact thing because it's the origin. And then the only thing we have is a vertical compression by a factor of a fourth. Okay, so we have some things down here. So for us, I don't want to keep you too long. I know I'm already at 10 minutes. I'm going to skip this for now. But I really want to do this one with you, and then we'll skip this too. So I just have one more that I want to do with you. So the first thing I want to do, guys, of course, is always find HK. So I'm plotting HK. HK is at 1, 2. 1, 2. And the next thing I look at is I look at the A value. And if you notice, the A value is negative. So I'm going to think in the back of my head that this graph is going to open down. And then before I do anything else, I'm going to go ahead and find some mapping based on my ordered pairs. Or I'm sorry, based on my A value. So again, from the vertex, if I go one place in a positive direction from the vertex, one place to the right, it is going to be -3 times the absolute value of that. So -3 times 1, I'm going down 3 units. Again, back from the vertex, if I go one place in the negative direction, one place to the left, it's going to be -3 times the absolute value of -1, which of course is still -3 when you do that math. So from our vertex, we are going to go over 1, down 3, over 1 to the opposite side, left, down 3. And we could even keep going here. So let's say I go 2 places from the vertex. -3 times the absolute value of 2, I'm going to go 6 down after I go 2 places to the right. I'm also going to go 6 down after I go 2 places to the left. And please remember, this is always starting at the vertex. So if I go to the vertex again, I can go over 2, and this time I can go down 6. Over 2 in the other direction, down 6. And there's your absolute value graph. So what's going on with this domain? It's still -infinity to positive infinity. What about that range? That range got flipped upside down. So the range is actually going to be -infinity all the way up to a +2. And then for your intercepts, I'm going to save you on how to do those intercepts. I'm going to do those intercepts with you in class. So I got to make a note to myself about all this fun stuff that we're going to do. And then for your transformations, guys, remember you had a vertical stretch by a factor of 3. It is a reflection in the x-axis. And this graph went 1 place to the right, and it went 2 places up. Oh, sorry, you can't see that. There you go. So for you to come back to me in class, here's what I would like for you to please do. If you could please, looking at all this, I just want you to please graph this one. And then, oh my stars, that's like so important. That's so important. That's not even a big enough star for how important that is. Please make sure you do number 5. So number 1, number 5, and then we'll pick it up in class.